Okay, so, sorry, be on just a second. You're gonna get a worksheet today, and the homework is 1 to 15, like we'll do probably half of them in class together. Drop number 14, Jack. But the warm-up I'd like you to do is using these identities, which you should already have. Work with them to figure out what those guys are.
Can I show you my work? Because I haven't been here.
Right.
I introduced. Yeah, she can't run so well. This is, I don't know if this counts.
Yeah, that was one of the homework.
What else? I did the homework with the textbook ones. I think you did the textbook ones. Oh, you didn't see my notes?
That's good. Those guys were the race check. But we didn't miss a good exit card.
I took them all on Friday. See?
One minus sine squared. Yeah. Oh yeah. It's one of her.
All right, guys, to figure this out, where we're getting to, we need to be able to use the identities and mush them around and change them. So, Fode, what were you saying about, like, any of this?
Cos squared would be 1 because it's gonna be 1 over.
Okay, let's look at this. Using this identity, what does cosine squared become? So get cosine squared by itself. How do I, what's attached to it? Sine squared. How do I move sine squared from the right side to the left side? Do I add, subtract, multiply, or divide? Subtract. So subtracting sine squared from both sides. That goes away. So cosine squared equals what? Not just 1, but 1 minus sine squared. Okay? Maya, looking at these identities, which one has a secant squared in it? The top, the middle, or the bottom? The middle, okay. Israel, using the one in the middle, what do I do to get that?
Subtract 10.
Subtract what?
10.
Subtract tangent squared from both sides. So secant squared minus tangent squared is going to equal what? 1.
For the first one, I get what you did, but why is that considered simplified?
Okay, it's not.
Oh.
I'm asking, okay, so I shouldn't have said simplify. Solve for. So I need you guys to get good at realizing if you see 1 minus cosine squared in these things we're going to get to are proofs or something. I say 1 minus cosine squared, you need to be pretty quick at figuring out that that means simplified, it'd be easier to use sine squared instead.
Okay.
Ode, what was your comment gonna be?
Oh, never mind.
No, never mind. Okay. Samara, which, oh, I ended up with that. Which one of these three, top, middle, or bottom, uses cotangent squared? The bottom one? I'm sorry, they wrote this one weird. So Tori, what am I gonna do to get this?
Yeah, you subtract cosecant.
Subtract, but I still have a 1, so subtract 1 from both sides?
Yeah.
So 1 minus 1 goes away. So Ferris, what does cotangent squared minus cosecant squared equal?
-1.
Negative 1. All right. Last one, which, do I use the top, middle, or the bottom? Middle, okay. Penny using the middle. How do I change, what do I do to make it look like, to figure out what 1 minus secant squared equals?
Would you do -1 to get the 1 on the other side, or would you do?
I want the 1 to be positive, so.
You do minus cosecant, and then
Minus cosecant?
it'd be 1 minus cosecant.
That's
Equals
secant. Where are you getting cosecant from? Okay. So I'm gonna subtract secant squared from both sides. But I still have a tangent squared, I need to move that. What do I need to do to move it?
Put it together such that it's negative.
So subtract tangent squared from both sides. So Nana, what does 1 minus secant squared equal? Negative tangent squared. Okay? Yeah. Okay. Do I have more of these back there? Yeah. All right. So I have a packet, all of 2 pages, but there's a staple, so we're calling it a packet. There are some identities on there that we already know, and I want to just make sure that you have them correct. There's some extras coming back here. So Carolina, can you pass some over? So, here's an extra one. Did you do the textbook homework? It was due 2 days ago, and I said I'd take it today. All right, did,
I don't remember what it's like.
Teddy, did you get one? Everybody got one? Ode, do you have extras, or
No, I have.
you have one? Okay. All right. So, one weird thing, sorry if you want to fix this. They used 5 letters for cosecant, I don't know why, but just know that it's cosecant squared. All right. So we know these identities already. The trig function's upside down, cosecant is 1 over sine, tangent is 1 over cotangent. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. All these co-functions work on complementary angles. And then under that on your page, I have these strategies. They're not a lot right now, but if you see this pi over 2 minus or 90 minus, think cofunctions. And cosine's cofunction is sine. Cotangent's cofunction is tangent. Secant's cofunction is cosecant. Maya? Oh, you only got one piece. There's supposed to be 2 pages. Can you guys make sure that you have 2 pages in the stapled packet? There you go. Pythagorean identities, we just worked with those, like, we might have to squish and change them around to do a proof. So here is an example. If we were trying to simplify this, sine of pi over 2 minus theta is cosine theta. This multiplied by cosine is still there. So cosine times cosine is cosine squared. This guy, the trig identities, sine squared plus cosine squared equals 1. Subtracting cosine on both sides, cosine squared. 1 minus cosine squared is sine squared, so we're going to get rid of this and put in what it's equal to. Does that make sense? This becomes sine squared over cosine squared, which is tangent squared. Is that crazy? Then this strategy, we might want to turn something into its reciprocal function, or we might just want to turn everything into sine and cosine and see how it goes. So you guys should be able to do, first, were there questions on any of these in the textbook? Nothing? Mine at the moment? Okay, well, let me know. Can you guys do these 3? They should be quick. Yeah. Has it been 10 minutes? Actually.
Has it?
Well, because we only have 30. Francis, you're fine. Sit still. You're good. Stay. When you're done those 3, if anybody wants to put them up, third period, they were like fighting over it, and all 3 people could put one up, that'd be great. Put it? Great. All 3 of you can write at the same time.
Which one though?
I don't know, you're the slow one up, so you get the one that's left over. Well, you gotta use the butt of the pen, I don't know why. You gotta turn it around. You think you could write with the out, but you gotta use I don't know. Ladies, make some space, let Florida get in there too. Are you not letting the symbol or? Okay, we're not there yet, so, but the first 3 make sense. We're good. All right. Okay, that's not wrong, but it doesn't help. So, hang on, let's turn cotangent into sine and cosine.
Oh, okay. Just see.
Is cosine on top or the bottom?
Cosine is on top.
So just keep it as cosine.
Just cos x.
Okay.
Yeah, all right.
I was gonna say, I don't know what that says. Okay, thank you. All right, guys. Comment. Keep the angles on it. through the whole thing because we might have more than one angle eventually, but we're gonna work with sine of A and cosine of B, so it matters what the angle is. Here, secant is 1 over cosine. They left the other side alone. Cosine divided by cosine, it reduces not to 0, but to 1. So this one is red. Here, cotangent. First strategy was to do 1 over tangent, doing the reciprocal thing, and that didn't help us. Feel free to back up, start again, turn cotangent into cosine over sine. Now the sines cancel, and you're left with just cosine up top. And this one, secant again is 1 over cosine, but cotangent is cosine over sine. The cosine's reduced to 1 over sine x, which can be called cosecant x. Right? Okay. All right. The next three caused a little more issue. And these are the ones we're doing. So you should be following along. All right, these look different than the other things. Any suggestion? It's not one of the strategies already. Yeah.
This is before, I did the Wartburg secant into 1 plus tangent part 2 and then the angle.
Okay, secant is 1 plus tangent squared. Okay. So how's that going to help me here?
It's just do 1 over cosine squared for each one, and then turn tangent to sine over cosine.
Yeah, but no, it doesn't reduce. It doesn't go away. So first thing was to make secant squared 1 plus tangent squared. That doesn't look cleaned up. Next idea, maybe we go to changing things into cosine and sine. I don't know what that does either. So those are not incorrect, but I don't see them being helpful. So the hint here, a different thing, is to factor. Is there some thing on each of those that I can factor out?
Cosine?
Cosine? Well, how about secant squared, which is cosine squared upside down. Francis, what happens when I factor out secant squared? What's left inside?
Oh, sorry.
Okay, guys. When you factor 2 out, what's left on the inside?
1.
Is it just x?
1 plus 1.
1 plus x. When you factor something out, we're like, hey, I see there's a 2 everywhere. I'm going to pull that out and divide each dude inside by the 2. 2 divided by 2 isn't 0, is 1. If I have 2 cookies and Anouk and I are going to each share them, you get 1 cookie, I get 1 cookie. 2 divided by 2 is 1. So like this, I'm going to divide each of those things inside by secant squared and pull that secant squared out. So this is 1 plus tangent squared. Look at your sheet. Do I have something in there that uses tangent squared? Some trig identity. Teddy, what's it say?
Which one?
Looking at the identities on the front page, which you're still on the front page, the identities at the very top, it's kind of tiny. Pythagorean identities, 1 plus tangent squared. What does it say that equals?
Secant squared. Secant squared.
Secant squared. So this stuff, using that identity, secant squared times another secant squared, what does that become? To the 4th. 2 squared times 2 squared is 2 to the 4th, x squared times x squared is x to the 4th. Okay, so the hint on this is factoring. Crystal, in this second one, number 5, is there something that both of them have as a factor?
Sine.
Sine x. When I take sine x out, what's left behind in this first group? If I cosine squared minus 1. Okay, this was the gross one. What, Margot, what does, using that identity, what does cosine squared minus 1 equal?
Squared minus 1.
Yeah.
Negative sine squared.
Subtracting 1 from both sides, subtracting sine squared from both sides. You didn't sound super confident about it, but you're right. Negative sine squared x. So Crystal did the factoring for us, and then look at what's left over. We might need to write this down on the side and manipulate it, change it till we get what this thing equals. You said it's negative sine squared times another sine. So Andre, what does that become? Sine x times negative sine squared. What is a times negative a squared?
Negative 8 to the third.
Negative a to the third. So what's this going to be? Negative.
Negative sine x to the third.
Perfect. Negative sine x to the third. Okay. Israel, the last one. Is there something that I can factor out in both pieces?
Yeah, cosine theta.
Cosine theta. When we take a cosine theta out, what's left inside?
The 10 squared, and we have plus 1.
Okay, Colin, using the identities, the Pythagorean identities on the front, can I get rid of anything?
The tan squared theta
Becomes
becomes a sine squared
not sine squared. Read it carefully.
theta. Sine squared over the sine squared.
Okay, the identities are these guys. So 1 plus tangent squared. There you go. Am I done or should I do something else?
Oh,
Just
good. You can simplify secant to make it, or no, the square. I think you're right.
product.
We're gonna be going over cosine, like the parentheses. Well, you write cosine with the angle of theta, parentheses, 1 over cosine squared. Yeah, and then,
So one of the cosines to the below.
yeah, so we're gonna turn back into secant, I guess.
Okay, and some clever chap in third period went from here. He said, you know what, cosine is 1 over secant. And multiplied by secant squared, reduced one of them and got secant slightly faster. Doesn't matter, I don't care, you can take the extra step.
On number 4, it says you divide both sides by secant squared, right?
Okay, there aren't two sides, there's no equal sign, it's not two sides. So I'm factoring out secant squared.
But you divide both of them, right? Divide secant squared.
Factoring out is basically dividing each of the inside things by secant squared and putting that guy out front. That's what I was doing. Works?
So you don't like divide out the, this cosine part of tangent because it won't help you?
Yeah, because,
Because you want it to match like the formula.
okay, so, all right. Third period did this too. Tangent is sine over cosine, so tangent squared is sine squared over cosine squared. All right, I'm gonna reduce one of these, and I get sine squared cosine plus cosine. If I want to mush those together, if I want to add fractions, can I add 1/2 plus 1/3? Not right away. What do I have to do to be able to common denominator? All right, so I'm gonna common denominator this. So I have sine squared plus cosine squared over cosine. Elon, looking at the sheet, what is sine squared plus cosine equal? Cosine squared?
1.
1. So that becomes 1 over cosine, which is the answer that we got. Much harder way to go. So Evan, you can do it, but sometimes it might be better to look around for another strategy if it starts going on gross. All right. What do you think we do on number 7 here? That opens page now. Carolina, what's your suggestion for the number 7? One minus sine x times 1 plus sine x. Okay, the Pythagorean identities.
-1 or 1.
These guys are squared. Is this thing squared? Then 1 minus sine x equal cosine? No. So
Do we like distribute it out?
yeah. So distributing it out. First times first is 1. Last times last is sine x. Inside times inside is negative sine x. And last times last is negative sine squared. Does anything go away, clean up?
Sin x.
We can cross out the sine x, the middle two.
Positive sine x, negative sine x goes away. And Ian, what do you see now?
But also isn't sin x.
That was a square, so it doesn't go away.
Would it be a positive?
Why does it become positive?
I don't know.
What does 1 minus sine squared x equal from that identity? Cosine squared. Okay, you guys should be able to do number 8. And it's quick, so what we just did with number 7, try also with number 8. Strategies similar. And these often people do what they change this in a way that makes sense. Okay. No, I mean, they're all traits.
Some of them look like
Some of them are, a lot of these are Pythagorean identities and second. That is not. Yes. So how can we tell if we need a Pythagorean identity or not? Sorry, what did you say was the thing we should look for? Squared. In this second problem up here, number 8, do I have a square?
Oh, yeah, so it's not.
Yeah, it's just usually it's
So Erin, it's not a Pythagorean identity kind of thing. So what's another strategy that we might do?
turn tangent to sine over cosine and then cancel out the cosines to get sine.
Turn tangent into sine over cosine, cancel out the cosines, and you just get sine. This is the kind of thing you might see on the quiz Friday. What do you think? How do we do the foiling thing?
Secant square x,
So first times first,
and then negative secant x,
outside times outside,
and then positive secant x,
inside times inside.
and then negative 1.
Andre, does anything go away? Can I smush anything together? What goes on with these guys?
Well, one of them, we just crossed it out pretty much.
Yeah, they cancel each other out. Secant squared x minus 1. What is that in the identity? What does that become? Right?
Tangent square x.
Positive or negative? Positive. So what do you think? We have tomorrow to go over more of these. The homework tonight is, we've already done 1 through 9. I am asking you to drop number 14. So you have 10, 11, 12, 13, and 15. There's 5 problems left to do on your own. Quiz on Friday. If you guys want that exit card retake, that is the quiz on Friday. You need to give corrections for that. You're allowed to do the retake this week.
Like the one in the car.
Does anyone have corrections for me to check down? A lot of you showed me yesterday. Andre, you can
Why do you always do that? You
Here. Yeah, like, if you're not working with and my correction that I've and great.
-1.